So exercise 5I is about inverses. So to find inverses, we know that we need to swap the x and y in the equation and solve for y. So to do that, here's an example. Find the inverse of y is equal to x squared minus 3. So what we do in the equation is we swap the position of the x and the position of the y, so that it looks like this. Now you'll notice that I've written the word inverse here. Okay, so in the exam, it's not good practice to just go from this equation here to this equation here. All right, you need to be consistent in your mathematical conversation, and so this is in fact the inverse of that. So a suggestion is that you indicate that you're now working with the inverse. You can write inverse function notation if you're given function notation with the power of -1, or you can write the word inverse like I've done here. So you go through and you solve. Now, if you want to do this on your CAS, put in solve, and then you can put the equation in exactly like it is and solve for x. What this does is gives you this answer here. Now, this answer here you need to be careful of if you're going to copy this straight down from the CAS in the exam, because what you should actually be writing is y is equal to, and this should be an x. So the other thing that you could do is solve for, and then in the equation yourself swap the y and the x before you put it in. Now you'll notice that up here I've written on CAS. Now on the exam, here's an exam hint. If you are working with a CAS exam, CAS use is assumed, right? So there's no need to tell the examiners that you're using CAS or that you've got your answers from CAS. Exam 2 is busy enough as it is. Don't waste your time writing by CAS, from CAS, using CAS. The examiners know that's how you got your answer. So let's just refresh our memory of inverse functions. So inverse functions are when both the function and the inverse are functions. That means both the original function and its inverse pass the vertical line test. So let's just have a little go at the vertical line test. So you can see I've got a little vertical line here, and I'm going to run this vertical line over our function y equals e to the x. So to pass the vertical line test, this green line, no matter where I put it, anywhere along the function, as long as it's vertical, should only intersect that yellow line once, and you can see that that's the case. So for a function to have an inverse function, it needs to be a function itself, so it needs to pass that vertical line test. It also needs to pass the horizontal line test. So here's a horizontal line. If it's going to have an inverse function, if its function's going to be, if its inverse is going to be a function, it has to pass the horizontal line test. So here's a little horizontal line, and again I pass this along the function, and no matter where I place a horizontal line, the horizontal line only intersects that function once. If that's the case, then the function's said to be 1-to-1. It's a 1-to-1 function. 1-to-1 functions pass the horizontal and the vertical line test and have inverses that are functions themselves. So let's have a look at some graphs of inverse functions and remind ourselves that they are in fact reflections of each other across the line y equals x, and that their intersection points lie on y equals x. For the sorts of graphs that we're looking at generally, which are in this chapter, which are exponential graphs and log graphs. Now, if you want a quick way to see an original function and its inverse function, you can use the lower right-hand corner trick, where you draw the original function in the lower corner, right-hand corner of a piece of paper, and then you fold the corner up and over so that the edges are parallel to the edges of the page. And if you look through, you'll be able to very faintly see the exact shape of your inverse function. And that's handy if you're asked to identify an inverse in the exam. The other thing that you need to be careful of in the exam, which is what I've got here, is if you're asked to draw an inverse function for a function that's already shown, you need to be very careful with the scale of the graph. So I've got two inverse functions, and you can see that the intersection points are clearly on the line y equals to x. That's where they cross. And if you're asked to draw this on an exam, that's what you want them to do. You want them to cross on the line y equals x. The other thing you want to make sure is that you get your scale right, so that this distance here is the equivalent distance for this distance here. And this distance here is the equivalent distance for this distance here. So they really need to be, as close as you can, mirror images across that line y equals x. Now please be aware that for some functions which are not increasing or decreasing functions, the intersection points are sometimes, you can see here, that here's one function, here's its inverse function, and that there's clearly intersection points on the line y equals x. These are the yellow ones. But you can see also there's intersection points that are not on the line y equals x. So let's look at finding inverses when we have a restricted domain and the impact that the restricted domain has on the inverse that's created. So here's an example here. Determine the inverse function of the function f, where -1 to 2 maps to reals. Now the temptation here is to pick the domain as being -1 to 2, which is correct, but then also in error picking the codomain as the range, and then just saying that the domain of the inverse is R, and that would be a mistake. Let's have a look at the graph and see why. So here's the graph of our function, and you can see that the domain is definitely -1 to 2, but that the range, which is the y values for which the function is defined, are actually from here to, didn't go high enough. And so the y value for this point here is in fact e to the -1. It's the y value when -1 is put in here. And accordingly, for this other end point here, this y value up here is in fact y for e to the x, and the x that we have up here is in fact a 2. And that's why our range down here is from e to the -1 to e squared. That's our range, non-inclusive. Which means if we look at the inverse function, do this again. So you can see our original function here with a domain of -1 to 2 and a range of e to the -1, e to the 2. Over here, I've drawn the inverse function, and you can see that the range of this function is from -1 to 2, that should say -1, and its domain is in fact from e to the -1 to e to the 2. So for the original function, that's the domain, and for the inverse function, you've got a completely different domain. It's not R. Watch out for those.